Okay, so welcome to this recording on factor analysis. So some of you have been requesting me to upload a video or share a video with you which explains how to do factor analysis. Just a few things first. Number one, please bear with me. This is not a very convenient way of for me to teach. It's very new for me as well. So please bear with me as I start explaining this procedure to you. Second is, it is not necessary and compulsory for all of you to do SPSS or use SPSS in your projects. It is not compulsory at all. It does not either mean that you'll be fetching more marks if you are doing SPSS. So this goes for both BCom and BMS. I'm recording just one video applicable to both the departments. So this is not a guarantee for more marks. So it just depends on your objectives. If your objectives are fulfilled using simple mean calculations or weighted mean, it's more than sufficient. You don't need to use this. But there are certain tools which are actually relevant. Now, one of them being factor analysis, and it's a very simple procedure, simple technique that can be used. This is only applicable to those students who have a large number of factors. So if you remember in the beginning when you were developing your questionnaires, I had told some of you, especially those students who were doing studies on analyzing the factors affecting purchase decisions or analyzing the factors affecting something. So I asked you to include more number of factors. So some of you landed up with 5-6 factors. I've asked you to increase the number of factors when I was designing, helping you design the questionnaire. So the reason was this: if you have more number of factors, you can actually reduce the number of dimensions to the most critical ones, the most relevant ones. So this is one of the reasons why it is done. Now you might suggest, so I had already got 5 factors, which is fine enough. Why did you ask me to increase it to 15 and then ultimately bring the number down? Well, the point is, there may be certain factors which you have skipped, or there may be certain factors which are relevant in reality, but is overlooked by you. So it is best to take into consideration all possible factors that are there, and then club it together into a smaller number of factors. I'll explain in a nutshell what happens in this particular context. So let's begin. As you can understand, in the very beginning, you'll land up with an Excel sheet like this. If you're doing your studies using Google Forms, if you're launching your questionnaire on Google Forms, so you'll be landing up with a data sheet like this. So it comprises of all the various data that are there. Okay, so I will be doing factor analysis, but just a quick recapitulation, you might say. You will not be getting these codes. So this is actually a sample data sheet I borrowed from one of my BCom students, Nikunj. So it would seem as if I'm doing the project for him, but it is not in reality. I will not be sharing this with him, so he has to do this fresh on his own. So this goes for all of you as well. So this is just a sample. Please follow the stages very, very carefully. I'll explain this as simply as possible. You can pause the video according to your convenience to understand what to write down. I'll explain everything: what to write down, how much to write down, and what is relevant, what is not relevant, etc. Just prepare only that part which I'm telling you. This is not a statistics class, so you don't need to study and understand everything that is there. Okay, so you will be landing up with data like this, not like this. So these are already codified data. So Nikunj has already done this from beforehand, as I've asked him to. So you'll be landing up with data like this. So what you need to do right now is recode this. So if you remember, this depends on whatever codes you have on your study. In the context of the current study, I think Nikunj has extremely important being 1, somewhat important being 2, neutral being 3, somewhat unimportant being 4, and extremely unimportant or not at all important being 5. So this is the codification that is done for Nikunj. It may be different for you as well. It may be the opposite. So please follow the codification that you have done initially. If you do this reverse, it means you'll be getting opposite results. So please be careful when doing the codification. And one more thing, I know some of you may land up with this problem. When you are coding this, what you will ideally do is use the find and replace option. So if you go on to change all the important, so for example, if there's an option called, this is not applicable out here. So if you have an option called important and very important or extremely important, and if you change all the importance to 4, then what will happen is by using the find and replace option, so important becomes 4, so extremely important becomes extremely 4. So that becomes a problem. So it's better that you first convert extremely important to 5 and then convert important to 4. And then similarly, if you have unimportant, leave unimportant first convert extremely unimportant to 1, then convert unimportant to 2, and neutral becomes 3. So this is one thing that you need to be careful about. Okay, now coming back to the factor analysis part. So why is this required in the very beginning? Let me explain this first. So I'll take an example, case in point, as you can see. So Nikunj has approximately 20, I think not approximately, he has got exactly 29 factors which he has identified. This is a study on brand personality of restaurant brands. So every individual has a personality of his or her own. Similarly, brands also have its own respective personalities, and restaurant brands are no exception. So you have a list of 29 factors out here which you have identified. So this is a self-developed questionnaire. So Nikunj just developed these factors on his own, and what he wants to do right now is find out if there is any way by which he can reduce the number of factors from 29 to, let's say, 5 or 6, which is much more presentable. So if I tell you that these are the important reasons why these are the important factors in determining the personality, or in the way in which a personality is perceived by consumers, and I give you a list of 29 factors, it seems very tedious. So it's of course much better if I give you a list of 5-6 factors. It becomes easy to comprehend. That's the reason we do factor analysis. Okay, so there are 29 factors. So as you can see, these are the codes. So for example, down to earth is one. The restaurant is down to earth. The restaurant is going to offer nutritious food. This restaurant is popular. So like this, you've identified 29 variables. So I have just highlighted this particular portion in a separate Excel sheet so that it becomes easy to understand. Yeah, so this is the highlighted one. So this is the sample sheet. This is the selected portion. What you need to do right now is, as you can understand, this cannot be done in Excel. I am not sure if it can be done in Excel or not, but to the best of my knowledge, factor analysis cannot be done in Microsoft Excel. So you need to use a software, professional statistical software for this. So SPSS is something that is already known to you, so it's a best bet. So what you can do is click on SPSS. I have already given you instructions to download. If one of you has SPSS, it would be great. You can help some of your friends out in this particular time. So the moment you click on SPSS, you open this software, you'll end up with a blank sheet like this. So there are two things to be taken care to take note of. So when you click on this, there's a default option called data view and variable view. These are two tabs. The first thing that you must do is click on variable view. You have already been taught SPSS to the best of my knowledge in your methodology classes, but still I'm repeating from the beginning just in case it becomes difficult to figure out. This, mind you, is the most tedious and time-consuming procedure in SPSS, to list out all the variables one after the other. So, in this particular case, it's all the more disastrous because Nikunj has got 29 variables or 29 factors. So, this is what you need to do. So, the first variable that Nikunj has got is, I think down to earth was the one. Yeah. So, down to earth. So, what you need to do is go to variable view. In the first name column, you have to enter the code. Now what is down to now one thing that you must remember is, in the name column you cannot enter anything in spaces. It accepts only code values, alphanumeric codes. So down to earth cannot be written as down space to space. It cannot be written like this. It has to be written in one word itself. So down to earth, see the way I'm writing this, so there is no space in between the words. Okay, so once you click on down to earth, this becomes the other data gets filled up automatically on its own. One thing I've requested to do is please change the decimals to 0 for all the ones. So the reason I'll tell you in a while from now. This part is important. In the label column, you can just write down to earth. If you want, you can write down in detail, this restaurant is down to earth, but for the sake of convenience, I'm just writing down to earth. So this is the first one. So this is only applicable for Nikunj's study. In your study, it's just a change of variables. Nothing else will change. You just have to enter the variables one after the other. And this is just a sample that I'm doing right now. This is very, very important, the values part. Please click on these three buttons that are out here. in the value part. So as it turns out in this study, I'll just explain this part to you. Nikunj has already codified this in the beginning. So 1, 2, 3, 4, 5. So here 1 means strongly agree, 2 means somewhat agree, 3 means indifferent, 4 is somewhat disagree, and 5 means strongly disagree. So these are the codes that have been used in the context of this study. So what you need to do is just enter these values one after the other. So 1, as I told you, was strongly agree. Click on add. So 2 is somewhat agree. Click on add. 3 is indifferent or neutral, whichever one you want to write. 4 is somewhat disagree. Click on add. And 5 is strongly disagree. Click on add. So once it's done, you can just click on OK. So the reason I asked you to change the decimals from 2 to 0 is this is exactly what will happen. If you click on 2, so the values become 1.00, 2.00. It just looks odd. You don't need decimal values out here. We're dealing with integers, so it's fine if you just keep it to 0. Number of decimals it is. So other things remain exactly as it is. Only one thing you need to change, that is measure becomes ordinal. Why is this ordinal? I'm not explaining this to you right now. It is not required, but just remember you're dealing with categorical data. Since you're dealing with categorical data, you require ordinal. This is all that you need to know right now. If you want to learn about this in detail, I'll explain this to you 1 to 1. Okay. So other things are not to be interrupted or done. I mean, you don't have to do anything with the rest of the tabs. Leave it as it is. Just the measure becomes ordinal. So like this, you have to go on entering the values of all the 29 variables. So if I start doing this right now, it becomes very tedious. So I've already recorded this in the past, in the beginning, it is. So yeah. So what you need to do right now is just enter all the variables over here. So as you can see, everything is pre-entered. So I'll just give you an idea about what is happening right now with regard to the variables. So you have got 29 variables from down to earth all the way to sophisticated in the 29th row. Now the labels are also mentioned out here. The values, what you can do is, instead of writing everything one after the other, 1, 2, 3, going on writing the same thing 100 times, you can just use the Control C, Control V. So you can, otherwise you can just click on copy and click on paste. Just go on doing the same for all the other ones, one after the other. So this is what you need to do. So just kind of Control C and Control V for all the ones that are there. For measure, you just have to click on ordinal, go on doing this for each and every one as it is. Okay. And everything else remains exactly the way it is. In the label column, you can just want to explain what it means. For example, just have a look. See, number 17, quiet env. So this is the full form is quiet environment. Yeah, quiet environment. So this is what it means. So this is the reason the label column is important. So it gives you a reminder that this is what the short form is. So the name that you have out here, it is not necessary that you have to write it in this way. You can write it as F1, F2, F3, whichever way you want to write it, factor 1, factor 2, whichever way you want to write it. It's entirely your call. Okay, so the data has been entered in the variable view column. Now you need to go to the data view column. So I'll delete this particular portion one more time just to show you how this works. All cases removed. Yeah. So once you click on variable, once you have entered all the data out here, you can click on data view. All the variables will be automatically listed on top. It's a default procedure. Now all that you need to do is copy paste the data from Excel to your SPSS sheet. So I've highlighted this particular portion for you so that it becomes easy to understand. We just need the highlighted data. So just click on Control C and I'll go out here and I'll click on Control V. That's it. And just give it some time. It'll take some time to load the data. Don't be anxious if it doesn't show up immediately. Yeah, so the data, as you can see, is already loaded. Yeah, so you have 100 and I think 10, yeah, 110 responses. So 110 respondents have filled up this questionnaire and all the data has been entered out here. Now what you need to do right now is find out if there is any way by which you can bring down the number of factors. I'll explain to you how this works and why this is required. See, you have factors or variables like this: clean environment, you have quiet environment. So if you want, you might think in reality there is no need for us to have two separate variables like this. What if we could combine this together? Or maybe, for instance, you can have honest, you can have let's say friendly, you can have spirited. So these ones can be merged in together. So if you might think in reality, instead of having three separate variables, we can club these together into one variable itself. So that is exactly the reason why we do factor analysis. So the whole purpose of this is to find out if there's a way by which you can reduce the number of dimensions. Okay, so this is your data view. So all the data has been entered. Now please follow the procedure that I'm telling you. The technique is very simple. You can stop the video according to your convenience and understand what exactly is the procedure and how to go about it. You need to first click on Analyze. Analyze is the sixth tab from the left hand side to the right. Analyze. Go down to the middle and you'll find an option called Dimension Reduction. So in Analyze, click on Dimension Reduction. Within Dimension Reduction, you have an option called Factor. Click on Factor. Now once you click on Factor, you will find a Factor Analysis tab opening up. Now in reality, what you will see out here is a large number of questions, a large list of questions that you have already entered. So this one is just for explanation that I have included only the questions that are required for factor analysis. In reality, you'll have more number of questions. For example, age, gender, the other demographic variables, other questions that you have, dichotomous or otherwise. So there will be a list of, let's say, 50 questions, for instance. So all the questions will come out here. So please be very careful in this particular next stage that we are going to go about. So the thing that you need to do right now is click on Control A. Select all the variables. As it turns out, this is only applicable in this particular case. If you have more number of questions, please do not do the mistake of selecting all the questions and transferring it over here. You just have to select only those questions which you want to reduce the dimensions for. So please be careful about this. Okay, all that you need to do is click on this particular middle button that is there, this arrow button that is out here, and shift all the variables to the right hand side. Now please follow the procedure that I am talking about after this. So the first thing that you need to do is click on Descriptives, which is the very top button. In the Descriptives column, tab, all that you need to click on is the KMO and Bartlett's test of sphericity. What is the meaning of this? What is its purpose? I'll explain this to you once I explain all the stages. After this, I'll explain this to you. What exactly is to be written down in a hard copy also I'll explain once I'm done with this. Continue. One more thing you need to remember is it is not compulsory that you are doing factor analysis. Sometimes you may not even get the right kind of results. For instance, in this particular study, I am not sure at all whether factor analysis can be done or not. So there's a test for this. That test is itself came on Bartlett's test of sphericity. That itself will tell us whether a factor analysis can be done in the first place or not. Okay, so it is not compulsory. Just because you've got 20 factors or 30 factors, it is not necessary that your data is strong enough for factor analysis to be done. Okay, so click on Extraction. In Extraction, all you need to do is click on Scree-plot and unclick Unrotated Factor Solution, the one that is there on the top. Unrotated Factor Solution needs to be unclicked. So uncheck this one and check Scree-plot. What is the meaning of the other ones? There is no need to understand all this right now. Just remember, everything else remains exactly the same. If you want to learn this in details about why this is principal components, which is the default one, and not, let's say, maximum likelihood or principal access factoring, I'll explain this to you in person later on. So this is principal components method. No one will ask you anything in detail about this. Don't worry about it. Click on Continue. Okay, next click on Rotation. In rotation, you need to click on Varimax. Only click on Varimax. That's it. Nothing else is required. Click on Continue after this. I am explaining in my own pace. You can just pause the video according to your convenience to understand. Click on Scores. There is nothing. I'm sorry. In Scores, you don't need to click on anything. So you can just cancel this. You just need to click on scores. Yeah, that's it. So the first three buttons are all that you require. So you need to click on descriptives, like I mentioned. Click on KMO-Bartlett's test of sphericity. That's it. In extraction, you need to click on scree-plot and unclick or uncheck unrotated factor solution. And in rotation, all that you need to do is click on Varimax. That's it. Okay, so we're all set. So please click on OK. So SPSS will take roughly a few seconds to do this. Okay, so this is what you will get. Okay, not bad. Okay, so I'll start explaining this to you from the beginning, how this will look. So you get a output sheet like this. So I'm going to click on OK in the previous tab that I had shown you. You will land up with the output like this. All that you need to do is just right click on this particular option on this table or whatever it is, click on copy and paste it in your Word file. There is nothing more than this that is required. Although I would recommend, since I tend to be a perfectionist in these things, you change the font according to the prescribed format that is given to you, and do not just randomly copy paste this into your Word files. Okay, you need to click on the following tables only in a separate Word file. Let me just open a Word file so that it becomes easier. Okay, so this is a Word file that I have opened up. You need to click on KMO-Bartlett's test of sphericity, click on copy and click on paste. This is what you will end up with. The second thing that you need to click on is ignore this communalities table. This is not required. This is very important. This is the total variance explained. Click on copy and click on paste. Okay, so this is done. I'll change this to a separate page. I'll shift it to a new page here. And you require the third one. This is the scree plot. This is a picture, so you need to just copy it as it is. If you want to do decorations to this is entirely a choice. If you want to decorate meaning change the color of the background, make it transparent, etc., you need to do it right here. So you need to double click on this one. If you double click on this, there'll be a separate chart editor that opens up, and you can change the background or whatever it is, fill and border. See, so the color is gray at the time. For the time being, you can change it to whatever you want. This is entirely your choice, and this is not recommended as such. Do not waste your time. But there are, in the past, I've seen many students who are not very satisfied with the scree plot diagram that is given as default, so they want to change it. So just need to this is the way by which you can do it right out here itself. Anyway, so click on copy and click on paste. This needs to be saved as a picture. Okay, so this is the scree plot. And one more thing you require is the component matrix is not showing in this case. Usually it's supposed to show. Even if it doesn't show, it's perfectly okay. You need the rotated component matrix. This is very, very important. Click on rotated component matrix. And let's go to the next page. Yeah, that's it. Okay, so for the time being, we'll use only this Word file, so it becomes easier to understand. Okay, to increase the page size a bit. Okay, so this is the first block or the first test that you need to do. If you remember, you clicked on descriptives, and from the descriptives you clicked on KMO and Bartlett's test of sphericity. KMO is basically the full form for KMO is Kaiser Meyer Olkin. So what I'll do is I'll just write it out for you. I'll just write it out for you. So it's KAICR, Kaiser, MEYER, Kaiser Meyer Olkin. Sorry, Kaiser Meyer Olkin, measure of sampling adequacy. I think this is the spelling. Yeah. So KMO's full form is this. Kaiser, Meyer, Olkin. These are the people who have developed this particular test. So this is for your information. Please do not write this over here. It is not required. So this is just for your understanding. I'm just highlighting this so that you remember that this is just for your understanding. Okay. And Bartlett's test, the other part is Bartlett's test. Bartlett's test is required so that you can find out whether a factor analysis is really required or is really feasible or not. So this is the test that will tell you whether a factor analysis can be done. So in many cases, it might so happen that you have got all these tables, you've got all these values, you've got all this free plot and the rotated component matrix and everything, but the Bartlett's test is saying that you should not move forward with factor analysis. So it is unwise for you to move forward, but I'll explain this to you in detail. Okay, I'm explaining this in my own pace. Again, like I'm repeating, you please pause the video and follow. From this point onwards, whatever I'm explaining is basically what you need to write down in your hard copy. Forget about the presentation part right now. In the presentation, you just need to include these tables and explain this in your own words. Do not write interpretations and anything of this kind in the presentation, the PowerPoint presentation. This explanation has to be presented only in your hard copy. Okay. So what is the primary purpose of this factor analysis that we're doing out here? To find out the most important factors. If I'll just write it out for you, or it's better that you remember or write this accordingly. So to find out the most important factors influencing, or to find out the most dominant factors influencing let's say perception of brand personality. So in your case, to find out the most dominant factors responsible or influencing the purchase of something or something of this kind. Okay, so the most dominant factors responsible for something or influencing something is the objective of the factor analysis. Okay, so to this end, the KMO and Bartlett's test of sphericity has been undertaken. So this is to find out or check the adequacy of the sample size and the significance of undertaking this kind of a factor analysis study. Okay, the first thing that you need to see or check is this value. This value is extremely important. See the significance value. It is this particular column. Let me just highlight this again. Yeah, this value. Do not highlight this in the hard copy. This is just for your understanding. You don't need to highlight anything. So this value has to be less than 0.05. So if it is less than 0.05, it means you can go ahead. It's like a green signal. You can move ahead with factor analysis, right? So the KMO test confirms the appropriateness of factor analysis, like I already told you. So the KMO test confirms the appropriateness of factor analysis. Ideally, the values should be greater than 0.5. So this is explained by the KMO test statistic, which is in this case 0.929. Okay, so this is ideally supposed to be above 0.5. So if you're getting values less than 0.5, it means it is not feasible enough. It is not worthwhile enough to move forward. So it has to be above 0.5. So please be careful about this. So in this case, it's very high. So 0.9 is very high. So it means it's perfect enough to move forward with factor analysis. Okay. So the sample size should be large enough to yield reliable estimates of correlations among the variables. The next part you need to write down is the Bartlett's test of sphericity. It is just one paragraph. Okay, so if the heading is KMO and Bartlett's test, all that you need to do is include the table, and below the table, please remember to put the table number. So this is how it is done. So please write table 1. I've seen some of your projects. There's a lot of errors that you have with regard to your tables. Table values and table numbers are always written at the top of the table. So if you do not want to do it this way, please click on click on the table itself and click on insert caption. Insert caption. It will automatically give you this one. So table 1. So if you want, you can do it this way and delete this particular part, or you can do this manually as well. Okay, so please be very careful about it. Please write the table number mandatory. Okay, so after this you just need to write the Bartlett's test. The Bartlett's test of sphericity now indicates the validity and suitability of the responses in the data set. So the p value is nothing but your significance value out here. This significance value, the p value is significant at the 5% level. Hence, it is appropriate for us to conduct factor analysis on the 9 variables, how many variables? 29 variables in this context of the study. Okay, yeah. So this is the Bartlett's test. So I'll repeat from the beginning just in case. So the first thing that you're getting is the KMO Bartlett's test of sphericity, this particular table. So Kaiser, the KMO measure of sampling adequacy is 0.929, which is well above the cutoff point of 0.5. It means it's perfect. So you can, the sample size is large enough for us to yield reliable estimates of correlations among variables. So what is the meaning of this reliable estimates of correlations among variables? You have 29 variables. So it is not necessary that all these 29 variables are far apart from each other. So if that is the case, 29 variables are unique enough. They're perfect enough to explain the factors responsible in the study. But in this case, as it turns out, see, you have got ultimately 4 factors. And let's come to this in a while from now. Which means there are a lot of correlations that exist among the variables itself, which means all the variables are not equally important, so they can be reduced. So this is what you're testing out using KMO. So the word itself will give you the hint. Sampling adequacy. Is the sample adequate enough? So some of you have been asking me, sir, I've got 30 responses, I've got 15 responses. So is that adequate enough? I am no one to comment on this. So it depends on your study. It depends on your objectives. It depends on the kind of data that you are getting. So this is the reason why doing this study. The Bartlett's test of sphericity, all that you need to do is remember the significance value. If it is less than 0.05, it's perfect. You can move ahead with factor analysis. It's like a green signal. So like I told you, this indicates the validity and suitability of the responses in the data set. Okay, so this significance value is your p-value. Okay. This is the first part. So the one thing that you need to remember is the writing part will remain the same for all of you. Please do not copy paste this table. This is not applicable for everyone. Your data sheet will vary, of course. So the data will vary, but the writing will remain exactly the same. So what will remain exactly the same? So for example, the KMO test statistic is, in your case, it has come to, let's say, 0.87. So 0.87, which is still above the cutoff point of 0.05. And significance value is 0.000 or whatever it is. If it is less than 0.05, it means it is significant at the 5% level of confidence. At 95% level of confidence it is. Okay, so this is table number 1. In case of finding difficulties in writing down this in the hard copy, later on I'll myself write this down in rough and I'll share this with you. You just need to adjust this according to your study. But I hope there shouldn't be any problem after this. Okay, the second table, like I told you, ignore the communalities table and move straight to the total variance explained. This is the this is table 2. So if you remember, this is something that I'm encouraging everyone to do. Please write the table number, it's very important. So this is the total variance explained table. This is the table that you'll end up with. One thing again I will recommend you to do is please follow the set pattern that I have given you. So this is what I will request everyone to do. The reason I encourage or emphasize so much on presentation is because it matters. So presentation really makes a difference in the long run. So if you land up with something like this, this copy pasted table, it's not going to reduce your marks. That's nothing to do with marks as such. But to an external to an external judge or a reviewer maybe, this seems run of the mill. This seems more cliched, and this one seems you've just gone one step further, putting in that extra amount of effort. Okay, so table 2, how can you differentiate yourself? You can just write one more thing. It's for all the tables that you have: source, author's own calculations. Okay, so this is what you can do. Sources, author's own calculations. Okay, so I am a perfectionist when it comes to these small things. There are many students who have been offended by this. I've seen this in the past as well. So why are you emphasizing so much on these small things? It's not so relevant to the study, but it's always good to make your study perfect. Okay, this table is important. This is the total variance explained table. Now see, you had 29 variables. See, 29 variables. Out of this, you have total of 4 variables which explain for roughly 67.78. It's roughly around 68% of the total variance. More importantly, see, it's explaining for roughly around 68% of the total variance. The others are not so significant enough. Now, how is this happening? If you remember in the SPSS output column, I'll go back to this one more time. In the analyze column, you can go to dimension reduction factor. See, this extraction column, there is a option that you had left default based on eigenvalue, or it can also be pronounced as eigenvalue, based on eigenvalues greater than 1. So only the eigenvalues greater than 1 have been selected in this particular case. As a result, what has happened is this. Since your eigenvalues are greater than 1, your total number of factors are this. This is a default setting only, so it is not why is this 1, can't we reduce the number of number to, let's say, 0.5 or 0.8? So this is not so relevant to your study right now, so do it exactly the way I'm doing it right now. So it can be reduced. There are many cases in my own presentations have reduced eigenvalues so as to suit the nature of my study, but that is at a high level. You don't need to remember all this right now. So eigenvalues can be reduced. They sometimes need to be reduced as well. It is not always. This is a very utopian kind of a setup, a perfect kind of a setup. So you need to reduce eigenvalues from time to time as well. But in this case, this is what you have got. I'll just highlight it again so that becomes easy to understand. But again, please do not highlight this in the hard copy. I'll explain what this means. So as you can see, the KM1 Bartlett's test in table 1, that is the previous table, has been succeeded by the total variance explained table. Okay, so according to this total variance explained or extracted table, the results will indicate the number of factors derived on the condition that all the eigenvalues or eigenvalue spelling is EIGEN. Okay, so this is where it is written. Eigenvalues are greater than 1. Okay, so eigenvalues greater than 1. So please write this. So according to the TVE, the results shall indicate that the number of factors derived on the condition that eigenvalues are greater than 1. What is the meaning of this eigenvalues? It is also not so relevant. It is just your understanding. Basically, this represents a specific or a special set of scalar variables, scalars, associated with the linear system of equations. Okay, this will make no sense right now, so you can ignore this. So just remember the word eigenvalues. This remembering of the word is important. That's it. Okay. So in this study, the total variance extracted table generates 4 factors. So it produces 4 factors. Since the others, the eigenvalues are less than 1. See, for the 5th one, it's 0.962. For the 6th one, 0.784. And it goes down all the way to 0.066. So all these are less than 1. So you have not selected them. Your condition was eigenvalues have to be more than 1. And only these 4 have been selected. This will come automatically. You don't have to do anything out here. You just have to write it systematically. Okay, so it is proof of the fact that factor 1, you can also write component 1 in this case. So it's just written as component, so I'm calling this to be component. So component 1 explains for 49% of the total variance, then followed by which you have component 2 explaining for 10% of the total variance, component 3 explaining for around 4.7 or 5% of the total variance, and component 4 explaining for 3.8% of the total variance. Just if you want, you can write this in detail. Okay. Alright. So this is what the total variance explained table produces. It will give you a summarized list of components that explain for the total variance among all the 29 variables. So this is what is the summary. So in a sense, what you're getting is out of all the 29 variables that you have had, you can basically bring it down to 4. So in Nikunj's study, you don't have to deal with all the 29 factors. So in future researchers, if I'm doing a research based on Nikunj's study, I will be basically dealing with 4 factors which he has identified in his study. So this is what is more relevant. All the 29 variables will no longer be relevant. So this is how research basically progresses. Okay, now one more thing. If you remember, I told you keep something default. The extraction method is supposed to be principal component analysis. So it was kept as default. Okay, what is this? So using the principal component analysis, you have extracted the variables according to the condition eigenvalues greater than 1. Okay, so for the time being, let us not consider the meaning of PCA, principal component analysis. Leave it. It will make your study unnecessarily tedious. So just write one more line after this. That the 4 factors that you have selected. So in your study, you may not have 4 factors. You may have 3 factors or 5 factors or 2 factors. So the 5 factors or the 2 factors or the 4 factors have a strong degree of interdependence and thus decreases as as you proceed down, as you move down. So this is typically the problem of multi-collinearity among variables. Okay, I'll just write this word down so that it becomes easy to understand. So this is a problem of multi-collinearity among variables. I think there's a spelling error. Is it? Yeah, double L. So multi-collinearity among variables. Okay, so this is the problem. Collinearity means 2 variables are very close to each other, so they almost explain for each other's variance. For the time being, this is more than what you need to understand. Homoscedasticity is the word that we often use, but it is not required. Okay, so I hope you understood what is meant by the total variance explained table. So 4 factors have been identified from the 29 variables that you had initially, 29 components. The third part is your scree plot. Scree plot, you don't have to explain anything, just write down one line as I am telling you right now. So just write developed by cattle. So this is very important. So just write developed by I think this is the spelling. The year was 1966. Wait, I'll just have a check. Yeah, 1966. So developed by cattle 1966. The scree plot is the graphical representation of the eigenvalues versus their component numbers. Component numbers are mentioned out here. So 1 to 29. So it's just a representation of eigenvalues versus their component numbers. So the scree plot is a graphical display of variance of each component in the data set. Which is used to determine how many components should be retained in order to explain a high percentage of variation in the data. What does this mean? Let me explain in detail. So this is basically, see, you have to move from one node to the next node. As you see, from the first node to the second node, there's a huge line. It's a huge deviation. From the second to the third, again, there's a massive deviation. From the third to the fourth, slightly small. And then as you move forward, see, the nodes become almost the same as each other. It's a very flat kind of a trajectory. The first few nodes are very steep. And then the slope becomes practically negligible, and then it almost becomes like a straight line. So the first 4 factors are sufficient. See, the first node, second node, third node, and the fourth node. These are the 4 points that you have already identified in your total variance explained. See the 4 ones. This is basically represented out in the scree plot. So just what you need to write is, like I told you, so it's a graphical display of variance of each component in the data set, which is basically used to determine how many components should be retained in order to explain a high percentage of variation in the data. So the length or distance from one node to another captures the eigenvalues. So this is basically the distance between 2 nodes is represented by capturing the eigenvalues. Okay, so it is observed out here the distance between the first 4 nodes rather is significantly greater than the subsequent nodes. Okay, this is all that you need to write in the scree plot. So again, a reminder, going back to my perfectionist talk. So you need to click on insert caption. So this is a figure. So you click on figure. It will automatically go below the selected item. So it becomes default. So figure 1. So you just need to write scree plot. That's it. If you want, you can write figure representing scree plot. Again, to make it professional. So click just write source, author zone, calculations or computations, whatever you write. Okay, so this is what you need to do. All right, so this is your scree plot. That's it. Scree plot. If you want, you can reduce the size. This is too large. We can bring down the size. Please definitely remember to lock this diagrams, whichever diagrams. I've seen many diagrams where it's wobbling along with the text. Outside the text. So your picture is in one page, your text for that is in a different page. It's because you haven't locked the or wrapped the diagram. So please click on position, or if you want, you can click on wrap text in line with text. So in line with text means it will go along with the data, the text that you're writing. It will not shift its place. Please be very careful about this. Okay, so you're writing the content for scree plot, as I already explained to you. After the scree plot, you're moving on to the rotated component matrix. This is table 4. I'm not writing this once again, or table 3, I guess. Yeah, table 3, or whichever be the table as applicable in your study. It may be table 20, 25, because you have other tables in other chapters as well. Okay, so rotated component matrix. This is the last thing that you have. This part is actually very important, so please pay attention. So following the scree plot, which portrays your 4 factors, we have extracted using the principal components analysis technique. So we now come to the rotated component matrix. So here, according to the RCM, the rotated component matrix, the variables will get accommodated in the factors. You have to basically list all the 29 variables into 4 factors. How is this done? I'll explain. So according to the RCM, the variables will get accommodated in the factors on the basis of their factor loadings. Remember this particular word. The word is FACTOR, factor. Oh my God, sorry. Factor loadings. This is the word. Okay, so it will get accommodated in the factors on the basis of their factor loadings, thereby giving you your final results. Okay, so this part is very, very crucial. Now, how is this done? Okay, so the rotation, if you remember, has been done using Varimax, using Kaiser normalization in 3 iterations, I don't remember the number of iterations. It is 8 iterations. So you just need to write this. So just write this in a sentence format. So what you're writing, the rotation has been done using Varimax with Kaiser normalization in 8 iterations. It will automatically come along with your RCM table. So you don't need to do anything else. All right. So now what you need to do is you have to select the variable factors. Okay, how is this done? Please pay careful attention. It's usually easier for me to explain this in person, but I'll try doing this over here as well. You have to select the highest number, horizontally. So for down to earth, which is the highest number out here, it is 0.449. This is the highest one. So you can just highlight this right now. Yeah. So the second one is nutritious food. For nutritious food, the highest one is, you can see, 0.660. So just keep this in mind. There is no need to highlight this. You just need to keep the table exactly as it is. But I'm doing the highlighting for you so that it becomes easy to understand in the next stage. Okay, so for the third one, the highest one is 0.819. For the fourth one, 0.571 is the highest. Then this one, no, this 0.528 is the highest. Then you have 0.825 is the highest one. Then 0.661 is the highest in this case. 0.841, 0.81. So you can, I hope you can understand what I'm doing. You have to select the highest number. This is what horizontally. I keep messing this thing up. So it is horizontally. So horizontally select the highest number. Okay. So in each row you have to select the highest number. Go on selecting the highest number. Again, please do not worry so much about the rationale or the logic behind this. This is just a sequence that you need to follow. If you really want to learn about this, please give me a call. I'll explain this to you in detail. Okay. The next one is spirited. 0.628 is the highest one. This one again, the highest is well managed stuff is the first one. This one is the highest out here. 0.687 is the highest in this one. 0.760. Then you have successful 0.783, successful spelling, I think it's wrong. 0.605, 0.715, 0.472 is the highest, 0.661, this is the highest. Okay, 572 is the highest, 0.572, 0.698, and 0.653. Okay, then 0.645, 0.513. Okay, so you just go on selecting the highest numbers. Okay, so 0.614, I hope this is the highest here. 0.614, 0.813, 0.649. Yep, so these are the highest ones. Okay, so this is the end of the rotated component matrix. Here all that you need to do is in rough, somewhere in rough, or if you want you can highlight this, but remove the highlighting later on, so that you can go on to the next table. Okay, so this is done, the rotated component matrix. You just have to write what I told you. So it has been done using Verimax, using Kaiser normalization in 8 iterations. Okay, now the components, now this is very important. This is what you need to write down. So the components, I'm just writing this for you. The components may be, just one second, check if the recording is working. Yeah. The components may be arranged in the following manner, as illustrated in table 4. Okay, I thought this is table 4 anyway. Okay, so we need to make a table right now. Click on insert. There'll be 4 columns. Since you have 4 factors, if you have 3 factors, then select 3 columns. If you have 5 factors, then 5 columns, like this. So you have 4 factors. You can write this as component 1. Okay, so like this, go on to explain, write down the remaining components. So this is component 2, this is component, sorry, component 3, and this is component 4. Alright, so in component 1 you have to just write down the highlighted ones. So see which are the ones that are highlighted under component 1. So you have the first one is just popular. So all that you need to do right now is just write popular. That's it. Okay, I'll just increase the number of columns and rows. That is, so the second one is speedy service. So just click on speedy service and paste it out here. The third one you can see is, so yeah, all the 4. So neat appearing employees all the way to well managed staff. So all these 4 are here. Just paste it out here. Okay. Well managed staff. Okay, this one is successful. Okay. Then you have clean environment and active. Okay, then you have cheap all the way to convenient. Right, so these are the ones that have been selected in component 1. Okay, move to component 2. In component 2, which are the ones that you have? None of these. You go all the way to here. So from cheerful to up to date. All right, then you have from comfortable and sensitive, and you have sophisticated. Right, so the third one you have down to earth. For component 3, then you have outdoorsy. See, your factors will change, your components will change according to the nature of your study. So you have, for example, price, you have, let's say, quality, you have, let's say, convenience. So you have a list of all these factors. So let's say 15 factors like this. So from this you bring it down to 5. So you have to just find out which are the ones that have been included in the RCM, the rotated component matrix, and find out the highest value on a horizontal basis, and just write down those variables out here in components. I hope you're understanding. If you are not following, please let me know. The second one I had done was outdoor C, that was the last. Then the remaining is daring. Then you have charming and tough. Just paste it out here. What else? Yeah, that's it. And the last one you have nutritious food. You have honest. You have visual appearing interior. You have wholesome and quiet environment. That's it. Okay, so this is the summary. So you have come up with 4 components. So this is the final result that you have got. Now listen very carefully about what's happening. We just do what I do best, make it professionally looking. So this is what you'll end up with: component 1 to 4, and all the 29 variables that you have had in the beginning have been organized under these 4 components. That's it. Okay. Now what you need to do right now is, since they have been decomposed into these 4 components, you have to rename these components based on a summary of this. This is where your researcher instinct needs to become very active. I thought the results would be something else, but it is not to the best of my satisfaction. So if you ask me personally, I would like to go ahead with a greater sample size, a more number of data, because see, I'll give you logic for this. Nutritious food, honest, visually appearing interior, wholesome and quiet environment doesn't really connect together to that extent. I would rather have, for instance, let's say, variety of meals out here, nutritious food together, into one. So this can be, my suggestion. If you just say, this is just an example I'm stating. So now what you need to do is make a summary. See the nature of the components. You have popular, you have speedy services, you have neat appearing employees, friendly, spirited, well-managed staff, successful, with clean environment, active, cheap, sufficient quantity, reliable and convenient. You need to rename all these factors or all these components into one. So component 1 has to be renamed. So this component that is there has to be renamed into something else. Okay. So this, I'm removing this particular word. So component 1 needs to be renamed right now. If you ask me, I'm just giving a suggestion. This can be renamed in anything that you want. Why does this need to be renamed is very important. In future, if I want to do a study, so like I told you, don't want to do a study with 29 variables. That's too tedious. So I need 4 variables or 4 factors. So Nikunj is already in a study found out 4 factors. I need to work on this, right? So you need to give me a new name for this. So I will work on that component. So what can be a summary? Let's start with an easier one. So component 1, since it has large number of variables, it becomes tedious. So I'll just start with a smaller one. So this one is relatively easy. So outdoor C, daring, charming. So this can be renamed as, for instance, let's say, I don't know. Outdoor C is there. So you have adventurous. Let's call it adventurous for the time being. I don't know. You can rename it anyway. This is where you are, like I told you, researcher instinct needs to come in. Adventurous. Okay, can be renamed as adventurous. Component 2 can be renamed as what can this be? Let's call this contemporary for the time being. I don't know. This is, I'm just putting in arbitrary names out here, but this is very important in your study. For instance, you have something like this as an example. You have, for instance, price and quality out here. So you can rename this as price quality relationship, or something like that. Or you have, let's say, convenience, you have, let's say, availability, you have price. These three into one component. So you can rename this as, for instance, and we let's say ease of access or something like this. So this is entirely your choice. The codification, the renaming is your researcher instinct that needs to kick right now. Okay, so component one can be renamed as, for instance, let's say hospitable. I don't know. This, you may not agree with me with any of these ones. I'm just picking up arbitrary names right now. And the last one can be honest, nutritious food. Let's say let's pleasant. I don't know, pleasant. Nothing is coming to my mind as of now. I need to think about this in detail, but this is what it seems apparently. So see, from 29 variables, this part is important. The inference is important, not the data. Please follow exactly what's happening. So from the 29 variables that you have had identified out here, 29 variables have been clubbed down into 4 components. The 4 components are now coming down to hospitable, contemporary, adventurous, and pleasant. So according to Nikunj's study, this is where the factor analysis comes down to, results come down to. You have identified 4 factors which basically explain for the total variance of all the 29 components that you have identified in your study. So this is basically the essence of factor analysis. I hope you have understood whatever I had to explain in this video. Like I mentioned, it is not a very convenient way of explaining for me. This is the first time I'm doing something like this, explaining something via video. But if you are finding difficulties in understanding how this is done, please let me know. I am also sharing this Word file with you. The Excel sheet, if you require, I'll just have to ask Nikunj, because since it's not my data set. So if he wants, he can. If he wants, it's entirely his call. If he wants, he can share the data with everyone. You can just have a look into how the codification has been done. I'll also share with you then in that particular case, should he be willing, the SPSS data set, the entry that is, and the output table. Okay, so this is all about that from the SPS from the factor analysis explanation. If there is any doubt, please let me know. I'll stop the video recording right now. I'll make another video for chi-square analysis for those ones who require it. Chi-square is even more simple. So factor analysis is, just remember one more time, is only applicable to those who have more than 15, 16 factors, or let's say more than 10 factors. So if you want to bring down the number of factors, you need to use this particular study. So if you are finding it difficult, at least one of you can write down whatever I've explained in for the purpose of your hard copy. I will edit it, and then you can help your friends after that particular point. Thank you.